Hello everyone, welcome back. I am Krishna and let's continue with the learning of product manufacturing capabilities of SAP Business Bydesign. In this unit, we will primarily take a deep dive into two sections. First one being product definition and product engineering, second one being resource load leveling. Let's start with section 1. To put things in perspective, from the standpoint of production process business flow, we will be discussing the function design. Let's start with the product definition process. Once the product is created, user can create multiple variants for the product. This is done with the use of product properties which are in turn assigned to product model. These are then applied to the required products. Variants can then be created against the product in the form of product specification by assigning properties derived from the associated product model. This specification can then be used in the business transactions, for example, order to cash, procure to pay, etc. In the subsequent unit, we will run through one such cycle. And in this unit, we will primarily focus on creating the product specification as one of the variant for a product. Let's now discuss the product engineering process. Product designs can be created in the system. Against a design, multiple versions can be created. From the design, user can then generate the production BOM. Let's take a quick demo of it in the system. In the system, I will be navigating to Work Center Product Development, and let me first create a certain property. I can create a property, let's say OS, which is the prefix I am using, and let me call it as a color. And I can create a property with some certain code values, let's say property value as R standing for red and B standing for black. This is one property I have created. Thereafter, I can actually create another property, again navigating from product development to product property. I can create another property, let's call it as size. And I would like to create this property with some certain values such as large and let's say XL extra large. So I have created two different properties. Why did I create these two properties? Because for the product that I am having, this product is actually having two different properties. It can be differentiated by the color, it can be differentiated by the size. So in order to assign the properties to the product, we first create a product model and assign the product in the product model. So let me just go to the product development and create a new product model. And let's see, let's say that I would like to assign these properties to one of the products that I am having in the system. Let's say KR underscore product. I am having one of the products which I would like to use it. So I am creating the product model for it. So I will say product model for KR product. Okay, and then I can assign the products. Let us say the product that I would like to use. Okay, now I can also assign the properties here, the properties which I just created, let us say OS underscore size, and similarly I can add another property, let's say OS underscore color. So while assigning the properties, I can also give the default value, but for now let's not give any default value so that user can actually maintain the values whenever they are creating a variant. So now I know that I have a product called KR product which can be differentiated by two properties, and hence I created the properties, I assigned the properties and the product to a model. Now how all these things are tied together when you are creating a variant? The way to create the variant here is by creating an object called as product specification. I can actually go and create something called as a product specification. When I am creating the specification, and if I am creating the specification for this product KR product, what will happen is system will automatically derive the properties from the underlying product model. Let's say I want to create a test specification. Let's say test underscore PRS. Okay, that's the name I would like to give, product requirement specification. And the product I would like to create it is for KR product. Now, the moment I entered the product, system automatically brought the properties down because it has read the product. From product, it read the product model. From product model, it derived the properties. So, user can maintain the values here, that the variant is referring to the large and the color it is referring to the red. He can then release it for further use. Now, at the end of this step, what we have done is we have created a product specification or a variant for a product, and the variant name is test underscore PRS. This variant can now be used in any of the process flows like order to cash, procure to pay, etc. for you to build inventory very specific to this variant. We will take the entire flow of this in the next unit. The other important element that I would like to discuss from the standpoint of product development is product design versions. Let us take an example of an existing design. Let me just open one of the existing designs. I have taken an example of P100401, okay, and then I will just take one of the released design and I will try to edit that. In this design, I can actually have lot of important parameters. So what exactly is this? I am trying to create a design and I can have some kind of an attachments with the underlying design attributes, okay, and then I can say that as per this design, this particular product has the components like P100101, P100109. You can add the design versions of the components. So this entire thing is actually happening in your R&D laboratory or the research wing who actually designs the products for you. Once you have done all of that, then from the design version, there is a provision for you to create the production bill of material. This is what we was referring in the earlier units, where the design section forms the basis as an input to the production master data. From here, let's say I would like to create production BOM. System will ask me what will be the BOM ID. Let me say that I am creating from the OpenSAP course. So let me say I am creating OpenSAP test, okay, and I can give the echo ID, but we all understand echo is a mandatory element for creating BOM. If we don't provide it, system will auto generate the echo ID. Let's not provide for now. Let's just provide the BOM ID and click OK. Now at this point, system generated the BOM for us with the name that we have provided. Let's quickly go into the production master data to check out whether the BOM has got created or not. So I will go to production bill of material under the planning and production master data, and I will search for the BOM ID that I have provided. System created the BOM ID, and within the BOM I will also see that my output product is P100401 and my input products are P100101 and P100109. As you can see, the echo IDs are automatically generated by the system because you have not provided the input. So this is the way the design processes will help you in the creation of master data and in the creation of the variants. Variants are used to execute your transaction process, and the designs will actually act as a fader to create your production master data. With that, we complete the section 1 of it. Let's get into the next section, that is the resource load leveling options. In the earlier units, we have discussed that the resource can get overloaded depending upon the proposals that are getting created. Okay. Now, the load leveling, so whenever the resource is getting overloaded, you have to perform the load leveling action. The load leveling helps to smooth the load between the multiple time periods to avoid overload situations. And during this process, they consider the requirement dates of demands. Within the load leveling horizon, defined by a start date and an end date, the load leveling selects all planning operations that have their start date inside the load leveling horizon. Load leveling will only happen on the unfirm proposals. Any proposal which is already freezed will not be touched by the resource load leveling. There is an option called as a compact scheduling, which adjusts automatically the operation relationships within the production proposal after a certain planning operation is rescheduled. There is also a provision for user to choose if the planning proposals within the planning time fence can be leveled or not. As I mentioned earlier, the rescheduling is only possible for unfirm proposals. Let's say that the proposals gets shifted. Once the proposal gets shifted, there is a chance that the dependent component proposals will get disturbed. For example, you have a production proposal for the finished good, and in order to achieve this production proposal, you have a dependent proposals on the components. If it so happened during the course of load leveling, this proposal gets shifted maybe three months down the line, it doesn't make sense for this proposal to stay on the same timelines. This has to be equally distributed. That is possible with the help of two methods called as top-down scheduling and bottom-up scheduling. The top-down rescheduling allows a downward rescheduling of the pegging network from the selected supply. The rescheduled top-down action propagates the available date change downwards through the pegging network. The contrary to that is the bottom-up rescheduling. The bottom-up rescheduling enables the planner to propagate the new scheduling from the reference document to other elements of the pegging network. If you look at this diagram, in the diagram we have a production proposal, okay, and which got generated from another production proposal. Let's say this is made up of cartridge, and the cartridge proposal has a dependent proposal here, and this proposal is having further dependent proposal called as purchase proposal. Now at this junction, when the proposal gets shifted, when one of the intermediate proposal gets shifted into the future, then user has to perform the bottom-up scheduling to move this proposal back to the main line. Similarly, from this proposal, a top-down has to be performed in order to move the dependent purchase proposals into the corresponding timeline. Now, let's take a quick demo into the system. We have seen earlier that we have a resource load because of the proposals that got created onto the cartridge. So, let me go to the supply planning and then let me go to the resource load. We see that there is already an exception for this. Let us see what is the exception for the resource, and I can open the exception list. System tells me that there is a resource overload on 29th of August. These are the proposals that we created in the earlier unit. Now at this point, what I can do is I can check the load graph, and system tells me there is an overload here, okay, and I would like to run the load leveling. During the course of leveling, I have to choose my dates, okay, such a way that the overloaded proposal is within those timelines. I am choosing the entire month of August because I know that the overload is there on the 28th or 29th of August, okay, and I am giving the horizon within which the proposal can be shifted. And as I mentioned, there are two options, whether you want to consider the planning time fence at the time of shifting the proposals or not. We have the option to select it. The moment I select this, at this point the load leveling happened and the load leveling is finished. If everything happened smooth, there should not be any more overloads. If you see here, the green represents the previous load and the orange represents the rescheduled load. System has rescheduled the load properly in such a way that it distributed the load onto the second day instead of overloading on the main day. So the load leveling worked perfectly fine. Now, what is the impact of this load leveling? Because this load leveling has removed the schedule of the cartridge. But if the cartridge proposal gets moved, the corresponding impact on the components also has to be taken into consideration. Let's take a look at the material flow of the components. So, I will go to the date on which we have the proposal, okay, and I see that this is the schedule which got pushed. So, I will go to the material flow of this particular cartridge, and then I can see that the cartridge got shifted here, to 28th, and then I can perform the top-down scheduling from here, which will automatically shift the dates of the components accordingly. If you see, the dates got shifted accordingly because the main proposal got changed. In the same way, user can perform the bottom-up scheduling as well from the reference document. With that, we complete the demo, and then we will quickly summarize what we have learned in this unit. In this unit, we have learned the product design functionalities, and then we also learned the resource load leveling and the rescheduling options that we provide. In the next unit, we will learn about two key concepts which assist in better handling of customer business requirements. Let's meet there. Until then, goodbye.